Voxel games have this quality that most people find incredibly satisfying, and I think I figured out why. See, most modern games use triangles to represent their scenes. They're empty, hollow, and far from reality. But voxel games, they represent the entire volume. They're dense, they're full, and they feel real. And I think that's important, which is why I was inspired to make my own game engine, ProjectV. And today, I am excited to share with you the progress I've made over the past few months. I think we can all agree that a powerful way to create immersive and entrancing worlds is with scale and detail. Take games such as Minecraft or No Man's Sky, for instance. Both games use voxels to represent their worlds, which creates a feeling that no other games can really compete with. So how do we achieve this in ProjectV? Well, one key part is to break our scene into chunks. This alone allows for some much larger scenes. However, we quickly run into a fundamental issue. These scenes are made up of a lot of data. Each voxel takes up around 8 bytes of memory, meaning that for a volume the size of 1024 cubic voxels, we are already at 8 gigabytes. Doubling that up to 2048 cubic voxels brings us to just under 70 gigabytes. Clearly, that won't work for the kinds of scenes that we want to render. However, there's a clever solution. Modern games typically use an LOD system to help deal with this, and this lets us go from small 1 billion cubic voxels to around 50 billion cubic voxels. Now, the way this LOD system works in ProjectV is beautifully simple. The highest resolution parts of each chunk are simply erased, leaving behind a version of the chunk that is half the resolution of the original. This simplicity is possible because of the nature of our octree data structure, which allows us to do these level of detail updates on the fly, resulting in seamless LOD transitions with minimal lag. Now, if we leverage these two systems together, we get the incredible ability to load each chunk and lower their level of details independently, allowing us to load scenes larger than the available memory. Okay, let's take a step back from all the technical stuff and just admire what these systems can actually do. Now, beyond our level of detail and chunk systems, there are actually 3 other systems that I've implemented. While each one of them changes the engine quite a bit, our new editing system stands out from the rest. Now, I want to make it clear that this is very much a prototype. It's very rough around the edges, but I was just too excited to not show this off yet. Editing systems like these are almost completely unique to voxel games. As you can see, we can make real-time changes to complex scenes. In this example, we're editing volumes of around 38,000 voxels in real time, and we can edit volumes all the way up to 4.3 million with manageable performance. The ability to edit voxel scenes in this way is crucial to many types of games. And the fact that the volumes are real and can be fully interacted with brings it to a level of immersion unmatched by other technology. Now, the way this works is surprisingly simple and straightforward. I created this concept of a default frame buffer, which holds crucial information such as the color or albedo, the surface info such as our normals and depth, and most importantly for editing, the voxel identity. This includes a chunk ID and a z-order encoded position. Together, these two values work as a sort of index, which allows us to figure out exactly which voxel is at any given pixel on the screen. This information lets us easily interact with our worlds, creating more dynamic and interactable scenes. I hope you've enjoyed learning about my game engine ProjectV and how some of the recent changes work along with the motivations behind the engine. If you're interested in helping out, first of all, I appreciate it a lot, and there's a link in the description to the GitHub repository where you can help out with the project. Anything is welcome, whether it's testing features, adding features, bug fixes, or even just spelling corrections. All of it is welcome. I think voxels as a medium are going to grow in popularity, which is why I think it's important to invest our time and our resources into making tools like these that allow that to become a reality. There are also a ton of other wonderful creators who have done a lot of work in the voxel field, such as Douglas, Tolly1998, Zima, and Ethan Gold that I'll have links to in the description along with some others. I highly recommend you check them out. Thank you all for watching this video. I hope you've enjoyed, and I'll see you all in the next one.